Lesson 1.6 brought to you by Rebel Snow Fighter from Hoth, I believe. By the way, I haven't checked. So 1.6 is talking about relatively speaking. So we're going to compare difference and relative difference. I sometimes label this as actual difference. I think that labeling is helpful. And then we'll talk about why is the relative difference often more effective in comparing differences. Then we're going to look at applying relative error, and then we're going to look at some conversion factors for square and cubic units. So if you read through this, our author asked you, let's say you loan someone 20 bucks and they only give you $10 back, or you win a 5 million lottery and you only get $4,999,990. In other words, in both cases, you're shorted $10. Which one are you more upset about? So let's start with our definitions of difference. We've actually already seen these. So difference is just the new value minus the old value. It's the exact amount of change between our two values, whereas relative difference is the difference divided by the original value. In other words, new value minus original value divided by original value. You might note that this is the exact same formula we used for percent increase and percent decrease. And yes, indeed, this is exactly the same thing. Note that negative values indicates that you've been shorted. So you have less than what you started with, and so in terms of percent increase and decrease, that meant it was a percent decrease. Positive values mean you get more than you started with. So our author says, well, let's take a look at the relative difference. So let's say you win the $5 million and you get shorted 10 bucks. We're going to write this as a fraction, not a decimal. Well, we can use that original formula where we do new minus old divided by old, but remember this top value is the actual difference. It's the amount that you have. Since we have been shorted $10, we would write this as negative 10 all divided by 5 million. Now, if that's confusing to you, let's go back and say, well, how much would you have received if you got $5 million and they gave you $10 less than what you expected? Well, the actual amount you would receive is $4,999,990. That's the new value, and we would subtract from that the 5 million, that's the old value, and divide by that old value, 5 million. So this calculation is the same thing as what we have here for this difference. Okay, so we're to write this as a fraction, not a decimal. Here it is. Note one of the little tricks we can do is cancel the zeros, and we get negative 1 over, let's see, 500,000. So let's convert that to a percent. The great way to do that is 1 divided by 500,000. I think I spoke wrong last time. There we go. So that is 0.0000. How many zeros do we have? 1, 2, 3, 4, 5. 0 as a decimal. Notice I did not put a negative up here because I got lazy. Let me put it in so we know that it's a negative. And that decimal is negative 0.000002. That's decimals. How do we convert that to a percent? Well, we multiply by 100, which has the effect of moving the decimal place 2 places to the right. So as a percentage, we're looking at 0.1230%, and that's a negative. So I skipped the part where he did the calculation for what happens if you were loaned 20 bucks. What does that equal to? That's negative 0.5 or 50%. So which one are you more upset about? Well, most people are going to be like, oh, if you borrowed 20 bucks and you only got 10 back, you're going to be more upset about that 50% because relative to the amount of money you got, $10 is only 0.0002% of the 5 million, essentially zero. Of course, any of us getting $5 million would probably be pretty happy about that. My response has always been, oh, you're not as worried about this? Can I borrow 20 bucks, please? Okay, so let's take a look at another question that highlights this idea of how do we compare relative difference with actual difference. So we've got Shauna and John found out they're getting a $1,000 annual raise this year. John went out to celebrate while Shauna yawned and said, yeah, whatever. Use this topic to describe what you think might be likely to account for this discrepancy. Okay, let's just do some basic things. Let's pretend Sean has a fairly small salary of $20,000. And let's pretend, we'll say that's John's salary. And let's say Shauna's salary was $50,000. So more than double John's. Let's calculate what is the relative difference or the relative change when they each get this $1,000 annual raise. So John's value would be this 21,000 minus 20,000 divided by 20,000. Now, note, we could have skipped this subtraction, this new minus old. We knew this was the amount of change, 1,000. So we could have just said this is 1,000 over 20,000. So John's raise relative to his salary is 1 over 20, or let's let Desmos do this for us, a 5% increase in pay. Not bad. That's actually pretty good, especially if we were considering this COVID era. 5% pay increase would be quite good. Many people are not even having a job, period. All right, so what's going on with Sean? So I'll skip this subtraction things, and I'll just do the 1,000 divided by 50,000. Would have been 51,000 minus 50,000. So this increase for Shauna is 1/50th of her salary. So what is that? It's a 2% raise. Now, I'm going to say even this feels pretty good. We shouldn't yawn. I wouldn't yawn at a $1,000 increase in pay. But you can see why John might be more excited, because he has a larger increase relative to his salary. And if we made these numbers even further apart, that's definitely what's going on.